Alright, we're going to graph an exponential. We know it's an exponential because the variable is in the exponent. So we're graphing y equals 2 to the x. The first thing to look at is the domain. Well, since we can take 2 to any power, then the domain is all real numbers, or negative infinity to positive infinity. This is important because when we set up a t-table, we have to make sure that we set up some negative values of x, some positive values of x, and 0, since nothing is restricted here. So I'm going to start at the middle of this graph. I'm starting at x is 0, and I'm going to go to the right. So I'll look at x is 0, 1, 2, and 3. So when x is 0, 2 to the 0 is just 1. When x is 1, 2 to the first is just 2. When x is 2, 2 to the squared, or 2 squared, is 4, and 2 cubed is 8. And if you keep going, you'll see that x is going towards positive infinity, and so is y. And we'll see that on the graph. So I plotted the points here, and as you go from 0 to the right, you can see that the red graph is rising quickly, and it is going towards infinity. Now let's go to the left. So we'll start with x is negative 1. This gives us 2 to the negative 1, which is 1 over 2. 2 to the negative 2 is 1 over 4, and then 2 to the negative 3 is 1 over 8. So if you think about these patterns, as we let x go towards negative infinity, then y is actually getting closer and closer and closer to 0. So as I graph that, we see that that's going to form a horizontal asymptote. So I've drawn the horizontal asymptote in green. So it's never actually going to hit the x-axis, it's just going to get closer and closer and closer. So we have a horizontal asymptote at the line y equals 0. Also, looking at the graph, we can now see that the range is 0 to infinity, and 0 can never be included. Looking back at the equation, you'll see that if you take 2, which is a positive number, to any power, you can't get a negative, and you can't get 0. So a range of 0 to infinity makes sense.